Welcome back to the Deep Dive. Today, we're peeling back the layers on something that should be, well, utterly mundane, but turned out to hide a really deep security flaw. We're talking about one of the most trusted utilities on millions of computers.
Yeah.
The humble text editor, Notepad++.
It's the ultimate paradox, isn't it? I mean, when software is so reliable, so constant in your workflow, you stop questioning it.
Yeah, you take it for granted.
Exactly. And yet, our sources detail how the routine act of just checking for an update could have been turned into a critical vector for delivering malware.
That's terrifying. I mean, Notepad++ is everywhere. It's the definition of a simple, stable utility.
It is.
So our mission today is to really understand how this update hijacking vulnerability worked, the mechanism of the attack, the crucial security steps taken in the new patch, and, why this whole incident just underscores the absolute necessity of integrity verification in every corner of the software supply chain.
Right. We're diving into a cybersecurity report that caught this problem just as it was unfolding.
So where do we start? What was the first sign of trouble?
Okay, so the source material identifies the core problem not in the text editor function of Notepad++ itself, but in a specific accompanying component, WinGUp.
WinGUp, right. That's the built-in updater, the tool that's supposed to keep your software safe.
The very one. And the first sign wasn't a crash or, a big obvious error. It was something way more subtle. Security researchers observed what they called suspicious traffic patterns involving WinGUp's communications. They were seeing anomalies when the software was just checking for an update.
Suspicious traffic patterns. Okay, so what does that mean? Are we talking about like a huge amount of data, or was the traffic going to the wrong place?
The second one, it was a substitution. When they analyzed the communication stream, they realized that in certain scenarios, instead of retrieving the genuine Notepad++ installer, the updater was being directed elsewhere.
So it was downloading compromised binaries instead of the real files.
That is the worst case scenario.
Yeah.
It creates a silent, high-trust delivery channel for malware.
I see.
Just think about it for a second. An attacker doesn't need to trick you into clicking a dodgy link. They just wait for you to do the responsible thing, update your software,
right,
and they substitute the payload in transit. Your own operating system sees a routine update from a program you already trust.
So here's the key question then, the one that unlocks this whole thing. How could WinGUp be tricked? Didn't it perform any kind of check to make sure the file was legit?
It did perform checks, but they just weren't strict enough. An internal review later confirmed that the crucial flaw was in how WinGUp validated the integrity and authenticity of the downloaded files.
So if it looked right on the surface,
if the file structure looked superficially correct, the system was just prone to trusting it. Yeah.
So this is where the traffic manipulation comes in. If an attacker can sit somewhere between your computer and the official update server, a classic man-in-the-middle scenario, they could just swap the file.
And the vulnerable WinGUp would just accept the rogue file and execute it. It really puts the issue in perspective. This incident is a textbook example of a traffic hijacking attack targeting the software supply chain.
Okay.
It requires an attacker to exploit weaknesses in the network path, maybe unencrypted traffic, maybe misconfigured networks. But the critical failure here wasn't just the attack, it was the lack of cryptographic defense on the receiving end.
The application was doing exactly what it was designed to do, just with fatal compromised instructions.
Yeah.
That makes the fix feel incredibly urgent. So let's pivot. Let's talk about the developer's response. What specific steps did they take to shut this down?
The response was swift and it was thorough. It all arrived in the latest release, which is version 8.8.9.
8.8.9.
And the goal wasn't just to patch one hole, it was to sort of build a cryptographic fortress around the entire update process.
A fortress. I like that.
Well,
so what does that robust verification actually entail? What layers of defense did they add?
They hardened both the main Notepad++ software and the WinGUp updater itself. They now perform 2 mandatory checks before the downloaded installer is even allowed to execute.
Okay, what are they?
First, they check the digital signature, and second, they verify the certificate that goes with it.
Okay, let's talk about that digital signature for a moment.
Yeah.
For a lot of people, that's just technical jargon. Why is it so fundamentally important here?
A digital signature is basically a high-tech tamper-evident seal. When the developers compile their software, they sign it with a private key.
Right.
This creates a unique cryptographic hash attached to the installer. When your computer downloads that file, it uses the public key from the certificate to verify that hash. If a single bit in that file has been changed by an attacker,
the signature verification fails.
it fails instantly. The whole thing just stops.
So if that file substitution happens now, the new process would just see the bad signature because it wasn't signed by the official developer, and the update stops dead in its tracks.
Precisely. If the signature or the certificate check fails for any reason, the update process is aborted. No untrusted code ever gets to run. It's a critical safety stop.
That's a huge addition. But the story takes a fascinating turn here because the sources reveal a bigger kind of structural change they made.
It does. This is probably the most significant long-term security change for the entire user base.
And what's that?
Starting with version 8.8.7, all Notepad plus binaries started being digitally signed using a legitimate certificate issued by a globally trusted third party, GlobalSign.
GlobalSign. Why is that shift so monumental? I mean, why does the source of the signature matter so much?
It matters deeply because it fundamentally changes the nature of trust. Before this, the Notepad++ project had, at times, required users to manually install a custom Notepad++ root certificate.
Oh, wow. So, okay.
Now, think about that for a second.
Installing custom root certificates sounds like, I mean, you're creating this massive, bespoke trust relationship that exists outside the normal security framework.
That's exactly right. Every time you install a custom root certificate, you're telling your operating system, I trust anything signed by this entity as much as I trust Google or Microsoft. You're creating an unnecessary trust anchor.
And if an attacker compromises that one custom root certificate?
They can sign anything, malware, spyware, phishing tools, and your computer will blindly execute it, believing it's legit Notepad++ software.
That risk alone just seems huge. So by shifting to GlobalSign, they're now relying on a certificate authority that's already trusted by, well, pretty much every operating system out there.
It's not just simplification, it's hardening the trust model. GlobalSign, as a public CA, has stringent security standards, legal accountability. A compromise would be catastrophic and detected globally. A custom root certificate has none of that rigor.
Which brings us to a key piece of actionable advice, something every listener really needs to hear.
Yes.
Because of this switch, the project now explicitly recommends that any previously installed Notepad++ root certificates be removed from your system.
You absolutely must do this. Go into your certificate stores, hunt for those old custom root certs, and just delete them.
Why is that so critical?
By removing those unnecessary trust anchors, you significantly reduce your attack surface. It cleans up the residual security risk left over from the old method.
Okay, so it's great that they locked the doors with version 8.8.9, but the sources also noted that, well, that the investigation into the exact hijacking method is still ongoing.
That's a crucial detail. They secured the client side, the program on your machine, to prevent malicious code from running. That's the immediate win.
But they still don't know exactly how the attackers were getting in upstream.
Right. Was it a vulnerability on their server, a weakness in the CDN, or purely localized network manipulation? They've committed to informing users once they have concrete evidence.
So they prioritized mitigation while the forensics continue? That feels like the right call.
It is. Security pros call it patching forward. You stop the immediate harm, then you analyze how the harm occurred.
So let's bring this all together. What does this mean for the person listening right now? Let's summarize the critical action points.
Okay. The primary recommendation is non-negotiable. You are strongly advised to upgrade to the latest release, version 8.8.9, immediately.
Right now.
This is your shield. If you use Notepad++ and you haven't updated in the last month or so, you are running vulnerable code.
And since the vulnerability involved file substitution, we have to stress source integrity, especially if you're doing a fresh install.
Absolutely. You must only get installers from the official Notepad++ website. If you download from a third-party site or some unofficial mirror, you're bypassing the very security fixes we just talked about.
You're introducing risk from the very start.
Exactly.
Let's connect this to the bigger picture for a moment. Why should someone who, say, works in finance or healthcare care so much about an updater for a simple text editor?
Because this incident isn't really about Notepad++, though. It's about the fragility of the digital supply chain. Every single application on your machine, no matter how small, relies on an update channel.
It's the hidden road everyone uses.
It is. And attackers know that security teams often focus on the big stuff, operating systems, enterprise software, leaving these small, ubiquitous utilities relatively unguarded at that update layer. When integrity checks are missing, that road turns into a very effective delivery vehicle for malware. This is why digital signatures are the last most critical line of defense. They confirm provenance, they ensure the code you're running is exactly what the vendor intended.
It's a powerful lesson in not confusing convenience with security.
That's the key takeaway. So just to make sure you have the critical facts locked down. First, the core flaw was in the WinGUp validation process.
Right, it allowed substituted files.
Second, the fundamental fix is version 8.8.9, which uses stricter digital signatures from the GlobalSign certificate.
And third,
critically, third, you must remove any old custom Notepad plus root certificates from your system. Minimize those trust anchors.
this whole deep dive just drives home the necessity of scrutinizing even the most trusted, smallest utilities on your machine. The greatest vulnerabilities often reside in the systems we rely on the most and, frankly, think about the least.
That's absolutely right. And building on that point about the ongoing investigation, consider this for a moment.
Okay.
Since the attackers were able to successfully substitute files before these new signature checks were implemented, what specific assumptions were they making about the default trust settings or maybe the unencrypted network traffic between your machine and the update server?
So were they betting that most users were running updates over plain HTTP? Or that some intermediary server was inherently insecure? What default setting were they exploiting?
It raises a really important question. What hidden vulnerabilities in our default trust mechanisms are we all currently living with, just waiting for the next attacker to uncover? That's something we're thinking about.
Food for thought, indeed. Thank you for joining us for this deep dive into compromised code and the critical role of supply chain defenses. We'll see you next time.